Go ahead, sister. Take it away.
All right. My presentation tonight will be done on the Babylonian number system, and in a short synopsis, it was done back in ancient history, where we had 360 days in a year. Back in those times when they lived in the desert, they would count in a set of 60, rather, where it would have been easier for them to cover a large amount of things such as items or products, right? Um, in the Babylonian number system, their representations of numbers is a bit different from ours, right? In this instance, they use, I would say, a right angle to represent number one because it does look like a right angle. One of the right angle would represent number one. Otherwise, number two, it continues to number three. Going up to number four, where it would have the same repetition going straight across, but it will start over like under the finishing right angle where you continue as four, right? So their representations of number is a bit, I would say, different or a bit unique to their culture, otherwise from ours, right? And it doesn't continue just like that because they only use two symbols going straight up to million, right? So when you reach to number 10, rather than using a right angle, as I would call it, the easier way for me to understand, rather than using a right angle, they go to an acute angle, or is it the right term, acute or obese angle thing? Because the two hands are open and you have the bit of a circle in the middle. I'm not sure if you guys can pick up what I'm trying to say. And this one has the same repetition going straight across up until about 40, 50, where it continues just as if you are using unit numbers, right? So when you're given the number, for instance, 47 to represent in a Babylonian number system, whereas our numbers we just write a 4 and a 7. In this system is a bit of a difference, right? Because you'd have to represent the tens as four acute angles, otherwise a seven as seven right angles. And it has to be unique because you cannot have a space in between the symbols at all, right? But the unique thing that I've learned about the Babylonian number system is that when they are using place values, right? In our number system, we go from 1 to 10 to hundreds, 1,000, so on and so forth. But in their Babylonian number system, when they're representing numbers on a table, the one section is multiplied by itself as in one. In the where we would have the tens column, that their tens column is represented by 60. So if you have a 10, it will be 10 multiplied by 60. Going up to 100, where we would have 100, their hundreds place is 60 squared. That is equal to 3,600 times the number given in that section. And even 1,000, it goes up to 60 cube. That is actually 21,600, right? So each section, where they use the 60 gap region, is it's easier for them to count. Otherwise, from us, we'd have to go single, 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 single. In their synopsis, they group each set by 60. So in their instance, when they're grouping hands and toes, they group them in sets of 20. So if you have 23 sets of 20, that equals to a 60. So if you want to find out how many sets of hands and fingers you have, you have to divide that 60 by 3 to get the actual amount in one set. That's how they work out their maths, which is a bit interesting to me. So for example, I have this example here. I'm not sure if you guys can pick it up as clear as how I'm seeing it. But
I'm seeing.
Yeah, man, I'm seeing it.
you get I use a upside down triangle to kind of get a better understanding. So
Mm-hmm.
in my 100 section, I have an upside down triangle rather. In my 10 section, I have a acute angle, and in my one section, I have 4 digits. While in working out that scenario, the total number is 74, but to work it out in their system, I'd have to write 14 times 1, that's in the one section, 60 times 1, which is a 10 section, and the answer is equal to 74. Meaning for our system, would have easier write 7 10s than 4 1s, but it's a bit tricky here. I went on to do one in the 100 section for you guys where I have 601, but it's represented as two symbols, a upside down triangle and an acute angle, where 1 times 1 would equal to 1, and in the tens column, the right angle is represented as a 10 there, so I would have to say 10 multiplied by 60 would have equal to 601. But in our instance, their system is a bit of a, I'll say, confusion at times. Further going down.
Go ahead.
Further going down to the, I would say, the 1,000 section, or their 60, I would say their 3,600 section, because it's 60 cube. It is, the number there is 3,665, but as I said again, it has to be worked out in steps to see the procedure going down, that the number given is multiplied by the actual set of numbers. That is 60 cubed times 10, which is equal to 60,000, and 60 times 1 would equal to 60. But again, 5 times 1 is equal to 1, so the answer there would have been 36,065. This is the ending of my presentation. Thank you guys for watching.
Okay, well done, Deandra. Let me hear from Keisha. What you think of our presentation?
It was good, but confusing.
Okay.
Yeah, it was confusing.
Babylon means confusion. But
Yeah.
it was very informative though, Deandra. And may I say to you though, what you just did is one of my first assignments as a student at Michael in a course called one of those methods course. So if you happen to go to Michael, you have already done the first assignment. Job well done. Very informative.
Thank you.
You're welcome. It was clear. But tell me now though, what is it that, how you felt when you were doing this assignment, as it relates to the aerobic induced system that we currently use in our number system? What jumps out at you from your experience?
Go again. I didn't hear the question.
Yeah, okay. In doing this assignment, right? What things came to your mind while doing this assignment?
The things that came to my mind, that I would say we live in an easy time, because back in those days you have to, the old typical old people that say if you have your head screw on your body.
Mm-hmm.
Yeah, that's what basically grabbed me, because to actually multiply a number by 60 cube and to be going up by 60, I'm not even sure what you call the fourth power, but to be going up by 60 is pretty much hectic. It's pretty much hard to understand.
Mm-hmm.
So what I get to understand is when you're trying to count, I want to say, bigger numbers or bigger amount of things, they use it to simplify it even, or to go even faster then, because they're grouping it in 60s. We have, like how we count 60 seconds make a minute, 60 minutes make an hour. That's the repetition they go by, but we stop at 60 minutes make an hour, literally.
Okay.
So it was pretty much interesting to find out that we are coming from a very diverse time, coming down to simplifying things where we're actually counting 1 as 1, 2 as 2, and 3 as 3. It was pretty much interesting.
Very good. All right, wonderful. And you recognize that mathematics is not all about numbers, right? 'Cause they didn't really use numbers;
No,
they used drawings.
yes, they use symbol.
Well, very good. So when you talk about math, that person thinks it has to do with numbers. No, 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 no. Have nothing to do with numbers. What we do with numbers is that we are representing an idea, right? We're representing an
Yes,
idea
yes,
symbolically. So I tell you
yes,
that from my class, we will be doing a lot of practical exercises. We'll be doing a lot of presentations. And as you do your presentations, you learn more from what is there. So, Keisha, looking
Yeah.
forward for that kind of thing, right?
Mm-hmm.
Better have your one ready when it's time to come. Go on and say.